So we know that over here, this is your stress Y25. And your shear Y25. We know the starting point is P over 2A and 0, right? So we know that this is equal to 50, right? And this slope is also P over 2A, right? So this distance, hold on, let me move some stuff. So we know that the distance from here to here is P over 2A cos 50. And we know that the distance from here to here is P over 2A sine 50. So that's why the first one is P over 2A sine 50. The second one is stress Y P over 2A. So from here, we can form the equation. So this is our equation number 1. We know that stress Y25 is equal to P over 2A 1 plus by cos 50. Okay. So so if you look at the book is also the same. Okay. Right. So this is our equation number 2. Right. So that is we are given equation number. So this equation is the same, right? And then the other equation is the same. So the other equation is the same. This equation is also the same. Or we have formed this equation also. Right? It's the same. Stress P over 28 over 2A 1 plus cos 50. Okay. So now if you look at the data that is given, okay, if we look at the data that is given to us, that the allowable stress is 600 pascal. I think that is where the confusion comes in. Okay. Remember, all these tests, that's where I think you all did not know this, okay? But I did mention this. All these tests are tested when they are unidirection added. So how they get this value over here is when they do a glue, okay, and they pull. For this data, they have a glue section and they do a torsion. They cannot do both at the same what? Same time. Okay. So that is where when you calculate your normal stress Y25, we know that this normal stress is equal to 800 times 10 to the power 6. Right? Because that is given to be the to the power of 3, to the power of 3. So due to the normal stress, you are going to calculate. So we're going to count due to normal stress, where the normal stress is equal to 800 times 10 to the power 3. Okay. So you have 800 times 10 to the power 3 is equal to P divided by twice the area. So the area is what? The area is like 50, 80. So 0.05, 0.08. Okay. 1 plus by cos 50. Okay. So 1 plus by cos 50. Okay. 800 power 3 divided by times 2 times by 0.05 times by 0.08. So one of the P that I got is equal to 3.896 times 10 to the power 3 Newton. Let me do it again. 800 power 3 times 2 times by 0.05 times by 0.08 divided by 1 plus by cos 50 close bracket. 3.896. Did they get 3.896? Okay, they got 3.9. Okay. And then the other one, due to shear stress where the allowable is equal to what? Is equal to 600. Okay, 600 times 10 to the power 3 Pascal. Okay. So you have 600 times 10 to the power 3. So now in terms of shear, is equal to P over 2A, right? Sine 50. So I will write on the side. So 600 times 10 to the power 3, P twice 0.05, 0.08, okay, sine 50. So from here, P is equal to 600 power 3 times by 2 times by 0.05 times by 0.08 divided by sine 50 is equal to 6,000 or 6.267 or 266 times 10 to the power 3 Newton. So you pick the lower one. So the P allowable is equal to 3.896 times 10 to the power 3 Newton. Okay. So as I said, it's been a long time since I did this question. I have not, I could not remember what's going on. The most important thing about this question is able to construct the stress state, okay, of the mole circle, okay, and then put into mole circle. You have to know your orientation really well. It's 25, it's 50, and I think this is the critical one. The stress average for both 0 and 25 have the same stress average. I think that's a critical one. Okay. Once you got that, I think constructing the circle is easy. And also for the fact that I did mention this enough, that the allowable stress and the shear are carried out in unidirectional, means one direction. So you only can use for either normal stress or the shearing stress. Any questions?
So when you say stress average for is same for 0 degree and 25 degree, it like is always true. Like so even like I know.
Always the truth.
Okay.
Always.
Makes sense.
Okay.
Thank you.
Always the same. Okay. So I know the solution manual is just that these are the numbers, right? And sometimes it's good to step back to know why it is occurring. Okay. That's why. Yes,
so
Opara.
If the question asks for the largest P, why are we picking the smallest as the answer?
If you take the big one, the material, the structure will fail. If you pick this, what will happen? Opara. The shear stress will, the normal stress will fail already, right?
Okay.
Right?
I don't completely get that part.
Okay.
Because the question asks for the largest P.
Yeah, you ask the largest, but if you pick too big, the structure will fail, right? Opara.
Okay, can you please explain that bit?
Okay, I'll explain. Okay, Opara, focus. Can you see where I put equation A?
Yes.
Now, if I put 6.266 times 10 to the power 3, divide by 2, 0.05, divide by 0.08, 1 plus by cos 50. What is this value going to be? Is it going to be greater than 800 or less than 800, Opara?
Oh, I see what you mean. So
I go. You see what I mean? I go.
Okay, that makes sense. Thanks. So basically,
that makes sense, you cheeky sort. It should have made sense like 10 minutes ago. So this will be equal to 1.2867 times 10 to the power 6 Pascal. So the structure will fail already. That's why we cannot load up to the highest value, you cheeky sort. Okay?
Makes sense. Thanks.
Makes sense. Okay, so this is, as I said, this question is, yeah, I would say it's not difficult. It's the interpolation, how you interpret the data. Like when you see this, I have not a clue why they do the 30, 25, 25. I have not a clue why. It's absolutely not necessary at all. Can you see that? Did we do that? We did not do that, right? We just know that it's rotate by 50 and we are good to go. Yes? Okay. So that is for question. Okay. So for this case, draw the shear force and bending moment diagram. For hello.
Sorry, before we move forward, back to homework 11, question 11. I was a little bit confused because of the way that you drew the shear. Question 11.
Can we do the next question first because the student asked first, Opara?
Okay, sounds good.
Okay. So I was asked to draw the shear force and bending moment diagram. Now, the student that asked me this question, can I find out from you what is the issue with this question first?
Sir, can you just form the equations?
No, what is your issue? Which part of this question that you are not, that is confusing you? Can you tell me?
Yes, forming the equations.
From point A to D, D to E, E to F, F to B.
That's correct. I'm just.
We will be here to 3 o'clock, you know. Okay, we'll be here to 3 o'clock then. Okay. So draw the shear force and bending moment. Okay, you tell me when you understand already, then I'll stop. Taram break. Okay?
Okay, sir.
Okay, you tell me, okay, I got this clear already. Okay, we don't need to do anymore. Okay. So for this question, we have to find, okay, we have to draw we have not find, we have to construct free body diagram first. Okay, we have to draw the free body diagram. So I'm going to sketch this out. Okay. So we have a structure something like that. And then we have a structure something like that. Okay. Then we have 400 pounds. We have somewhere well here 1,600 pounds. We have over here 400 pounds. Okay. So at point C, right? So if I'm going to call this X and Y, okay, and this is rotation about Z, okay. So I'm going to label this at point A, point D, point E, point F, point G, and point B, right? So at point C, is allowed to go up and down, right? It cannot go in and out. Okay, it cannot go in or out. So we know that there's a reaction, or left and right. We know there's a reaction at CY or CX. Right? We know that it cannot go in the X direction. It can move in the what? Y direction. Okay. Then if we look at point G, right? Point G, it does not allow it to go left and right or up and down. So I'm going to have a force down here known as my G x, and I'm going to have 1 up here known as our gy. Okay, up to now it's okay, right? So